All right, so this is one warm-up slide. And this is your second warm-up slide. So there's no wrong or right answers for these slides. The objective for today is that you are going to apply least common multiple and greatest common factor to situational problems. So it's kind of like word problems for the LCM and GCF. All right, so the first example says Sam and Martha are the local names for two lighthouses that guard a particularly dangerous part of the coast. So Sam is a lighthouse, and Sam blinks, and so does Martha. Sam blinks a light every 12 seconds, and Martha blinks every 8 seconds. They blink together at midnight. How many seconds will pass until they blink together again? So you first want to be thinking LCM or GCF. Well, the next time that they're going to blink together, I know it's going to be a number that's larger than 12 and 8, so that's going to be the least common multiple. So on my slide, I'm going to choose orange, and I am going to highlight that I am doing the least common multiple for this problem. All right, so that means I need to list out multiples for 8. So my multiples, I'm going to do 8, and my multiples are 8, 16, 24, 32 are the multiples. And I'm going to put some spaces here so I know those are my multiples of 8. Then I'm going to list out my multiples of 12. So 12, 24, 36. Do I see any number that's the same? I do. So I am going to, oops, that's a little too small. Circle the number that I see the same, which is 24. So my answer is 24 seconds. So after midnight, 24 seconds will pass before they blink together at the same time. All right, example 2. Carlos is packing sacks full of treats for a party. Every sack has exactly the same number of each treat in it. So every sack has the same number of treats in it. Carlos has 20 granola bars and 30 popcorn balls. What is the greatest number of treat snacks Carlos can make? How many granola bars and how many popcorn balls will be in each sack? Okay, so I have to be thinking about GCF or LCM. And if I'm making treat sacks, and it's going to have the same number of snacks in it, I know that my number is going to be smaller than 20 and 30. So I am going to be finding the GCF for this problem. And instead of crossing it out, I'm going to highlight it. So this problem, I'm finding the GCF. All right. So what is the greatest number of treat sacks Carlos can make? So I have to list the factors because it's the greatest common factor. So my factors of 20 are 1, 2, 4, 5, 10, and 20. And then for 30, my factors are 1, 2, 3, 5, 6, 10, and 30. Oh, I'm missing 15. So 15 and 30. What's the largest number that's the same? And oh, I don't want to do that. The largest number that is the same is 10. So that means there can be 10 treat sacks. And if I make 10 treat snacks, I'm going to divide 30 popcorn balls into 10 treat snacks, there will be 3 popcorn balls in each sack. All right, the next example, this is actually number 1 on your class work. So Michaela is thinking about inviting some friends for tea and cookies. She has 24 teacups and 32 large sugar cookies. She would like to give each friend the same number of teacups and cookies with none left over. What is the greatest number of friends she can invite over, and how many cookies would each friend receive? Okay, so I have to figure out if I'm finding the greatest common factor or the least common multiple. And if I'm going to invite friends over, then I'm going to need to have less friends than I do teacups or cookies. So I am going to be finding the greatest common factor. All right, so I'm going to list out the factors of 24. So 1, 2, 3, 4, 6, 8, 12, and 24. Oops. And then I'm going to list out the factors of 32. 1, 2, 4, 8, 16, and 32. So the largest number that I see is 8. So that means that she can have 8 friends over. And if she has 8 friends, and we divide 32 cookies by 8 friends. If I take 32 and divide by 8, each person will get 4 cookies. Example this is number 3 on your worksheet. So when you guys get to the point where you're working on your own, then this one is number 3 on that worksheet. It says, Marshall Elementary School is selling tickets for a raffle to benefit their arts department. As an added incentive, every 12th student to buy a ticket receives a homework pass, and every 15th person receives a hat pass. Which number student will be the first to win both prizes? So there's lots of students coming in, and I know that every 12th student receives a homework pass, and every 15 receives a hat pass. And what student is going to win both? Well, that's going to happen after the 15th person comes in. So I am going to be finding the LCM, the least common multiple. So I am going to be finding the least common multiple of 12 and 15. So I'm going to list the multiples of 12. So 12, 24, 36, 48, 60, 72, and 84. And hopefully that's enough. And then 15, the multiples of 15 are 15, 30, 45, 60, 75, 90. And I notice that 60 is the smallest number that is the same. So that means that the 60th student will get both prizes. If you want more help with figuring out the situationals with GCF and LCMs, like word problems with them, here is a link that has a video with a little bit more